Hello students, welcome to Max Beyond Marks channel. Understand first, marks will follow. If you understand the concept, automatically marks will follow. In today's video, we are going to see patterns in perfect squares under the chapter Squares and Cubes. In our previous video, we saw that only certain lockers remained open. Do you know why? Because those numbers were perfect squares. But today, we are going to discover a hidden digit secret inside the square numbers. First, let's recall what we did in the previous video. That means I said only 10 lockers were kept open. That is nothing but we have solved a puzzle where first person will open 1, 2, 3, 4 all. Second person will toggle. That means if it is open, he will close, or if it is closed, he will open 2, 4, 6, 8 like that. Then third person will toggle 3, 6, 9 like that. We went on, and finally these lockers remained open. First locker, fourth locker, ninth locker, till this we did. But they said to do till 100. But we couldn't do. You could have done it. If you have done it, let you recall what are those numbers. The next number will be 16. The next locker will be 25. The next locker will be 36, 49, 64, 81 and 100. Okay, that means totally there are only 10 lockers left to open in that puzzle. And you know these numbers are nothing but perfect square numbers. So this is square of number 1, this one 1, this is the square of number 2, 9 is square of 3, and 16 is the square of 4, 25 is the square of 5, 36 is the square of 6, 49 is the square of 7, 64 is 8, 81 is 9, 100 is 10. So for 10 numbers, we found the squares. Yes, my dear children, here in the first line, they are square numbers. And in the second line, the numbers are corresponding numbers for that which squares are written in the top. That means 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, like that up to 10 square. So here up to 10 square it is there. 10 square is 100. Now what's my question is, just can you recall what is the ending digit secret? What are those ending digits? You observe the ending digits alone. Here 1 is there, 4 is there, 9 is there, 6, 5. Again 6, 9, 4, 1, 0. So here 1 is already repeated, 4 is repeated, 9 is there, 6 is repeated, 5 is there. That means here only 1 comma, the numbers what are all here present in the last digits are 1 comma 4, 1, 4, 5, 6, 9 and 0. Now, why this is very important? Very, very important, because there is no other number will end and that will be a perfect square. It cannot be a perfect square which ends with 3, which ends with 7, which ends with 8, which ends with 2. It cannot be a perfect square. That means, what about the 11? That means 11, 10 up to 10 only we did. What about 11 square? It is 121. Again, the last digit is 1. What about 12 square? 12 square is 144, 144. The last digit is 4. Again 4 is here. And 15 square if you take, it will be 225. That will be here 5. So within these digits only the ending numbers are decided. Are you able to understand, children? So what you observe? These are the patterns. So this is following a pattern. What pattern it follows? In this, suppose they're asking, check whether 48 is a square number or not. Surely you can say, no, it is not a 48 is not a perfect square. But if they ask 59, yeah, ending digit is 9, is it a perfect square? No, we have to say it may be a perfect square or may not be a perfect square. Why? Because for 59 is not a perfect square. What is the conclusion? The numbers ending with 1, 4, 5, 6, 9 and 0 may be a perfect square. Very important. What is that? May be a perfect square, but not compulsory. But the numbers which are not ending with these numbers, that is 2, 3, 4, 5, 6 is there, 7, 8. These numbers, if any number is ending with 2, 3, 7 or 8, we can say that it cannot be a perfect square at all. So any number, even if you take 1, 5, 7, 9, if I write, you may say it may be a perfect square because the last digit is a 9. But if you say 1, 5, 7, 8, if they are given, then you can clearly say this is not, it cannot be a perfect square as it ends with 8. But this one, it ends with 9. So what you are going to say means it may be or may not be a perfect square. Are you clear? Okay. This is pattern number 1. Shall we follow to pattern number 2? Now, take the square numbers. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square is 25. Okay, enough. Up to this, we will derive it, I hope so. Okay, now check these two numbers. What is the difference between those two numbers? That means difference, I am using the word. Difference means what? Larger minus smaller. Subtract means that is difference. 4 minus 1, 3. Here, 9 minus 4, 5. Here, 16 minus 9, 7. Here, 25 minus 16, 9. What do you observe? The difference between any two consecutive numbers is an odd number. Is it interesting or not? How many patterns are there in perfect squares? You yourself can dig in internet and find out so many patterns because these are all interesting. Now you see the squares of numbers are 1, 4, 9, 16, 25, etc. But the difference of those square numbers are 3, 5, 7, 9. Next number will be 11, 13 like that. And hence the difference of two consecutive squares, very important. Okay. Suppose here I am using the word consecutive. What is the next number? Okay, consecutive only they are saying consecutive number. Then what is the difference between these two? That means alternate numbers. 9 minus 1, 8. 16 minus 4, 12, even number. 25 minus 9, 16. Okay, that is an even number. Okay, so like that, if you leave one number and they are coming as even number, will it be true for all the numbers? I don't know. You have to check it, verify. If it is any number you are able to follow which is not satisfying this rule, please comment in the comment section. Then only I can say that you are actively participating in the video. Is this an enjoyable one? Okay, shall we go to next pattern? Next, we'll go to pattern 3. What is that? I'll write 1 square equal to 1. 3 square equal to 9. 5 square equal to 25. You can observe I am doing something purposefully. What is that? I am writing only odd numbers. 7 square equal to 49. 9 square equal to 81. Then 2 square, okay, equal to 4. 4 square equal to 16. 6 square equal to 36. 8 square equal to 64. 10 square equal to 100. What do you observe from both the things? Yeah, in the first one, 1 square is 1, 3 square is 9, and 5 square is 25. But all the numbers are odd numbers I have chosen. But the ending digits of the square number is also odd. That means that is an odd number. So the square of an odd number is always odd. Yes, can you conclude? Yes, 11 square is 121. It will be 21 square also, it will be ending with 1 only. Okay, 441. Yes. Then 2 square is 4, 4 square is 16. Here also you see all the squares of even numbers ends with even numbers. That means that numbers also even only. One more thing you can observe. 19591. 195 increasing order. Again 91. So if you write like this, it will be there 19591, 99 and 11. What about year? 4664, 4664, but 0, okay, in the last 0. Now one more important pattern is there for this one also. That means zeros. Okay, that ending with zeros, there is a pattern which is very important pattern. Okay, let me see in that pattern 4. Okay, ma, what is that? Pattern 4. Pattern 4 is that one also. Why to leave that? You take 10 square equal to 100, because writing square of zeros is very easy. One square is 1 and 0, it will become double. Then if you write 100 square, it will be, okay, what about that one? 1 0 0 0 0, 4 zeros. 100 square is 10,000. But what about 20 square? 20 square equal to 400. 30 square equal to 900. Then 40 square 40 square equal to 1600. What you observe in all these things, you can see that there are only even number of zeros. What is it? You can see in any number square, there are only even number of squares. Suppose if I write 4000, will there be a square root for this one? Means no. Just like that, you can say it is not the square of any number. It is not at all possible, because the ending digits are having 3 zeros. Are you clear? When we observe carefully, mathematics reveals patterns, and we understand patterns, mathematics becomes easy, so that without memorizing, you can do any number of sums. See you in the next video, where we explore more about squares and cubes. Until then, bye from your Pragasam sir.